Hello, so this is going to be my first math recording, so bear with me. I'm going to be focusing on prime factorization. Prime factorization is an incredibly simple tool in math to break down larger tasks. One of the uses of it is reducing fractions, balancing rational polynomial equations and expressions, cross-reducing larger, fractions in larger equations. It's really helpful if you are dealing with massive numbers. It's really helpful if you are not very good at memorizing your multiplication tables, or just mentally seeing what numbers go into what numbers. So I'm going to go ahead and show you that, and I use this a lot because I'm lazy, and some days I'm just dead tired and I can't add 4 plus 4, so things like this are really helpful. I'm going to start off with the number 12, and 12 needs to be, let's say we need to reduce 12. We need to find out what the prime factors of 12 are. So what you do is, or what I do, you can do this however you want, but I draw an upside down division bar. And then I think of a prime number that would divide nicely into the number 12, and it happens to be an even number, so I'm going to use 2. 2 goes into 12 6 times. So I put the 6 down there, and I draw another division bar, and I lather, rinse, repeat. What goes into 6 that's a really nice prime number? Once again, an even number, so I use 2. And 2 goes into 6 3 times. 3 is a prime number, so it can't go any further. Now, to back up a little bit, a prime number is any number that cannot be divided by anything other than 1 and itself. 7 is a prime number. 6 is not a prime number. You've got 2 and 3 can go into 6. 17 is a prime number. Only 1 and 17 can divide into 17. Nothing else. So this will become more important the farther you go along in math, in algebra specifically, which is basically just practicing your skills mathematically before you go into applied mathematics like calculus and trig. Algebra's fun, but there's only so much it can do. So when you get the basics down like this, it really makes the more involved math easier. Okay, with 40, you have 2 ways you can do this. You could do 2, because it's an even number, but it's also a multiple of 10, but that's not a prime number, so you wouldn't want to do that. It's also a multiple of 5, which is a prime number, so we could do 5, and that would break, 5 goes into 40 8 times, and I'm going to do my little bar, and 8 has a prime factor that will go into it of 2, and 2 goes into 8 4 times. One more bar, 2 goes into 4 2 times. So now you've got your prime factors of 40. We're going to do 55. 55 is simple because the only prime number, we can't put a 2 into 55, can't put a 3 into 55, we have 5. So we're going to take a 5, and 5 goes into 55 11 times. 11 just so happens to be a prime number. We can't break it down any further. It's wonderful. Next is 108. This is another number that you could do many different ways. You could divide it by 2. You could also divide it by 3, since 1 plus 8. Okay, here's a trick. To find out if a large number can be divided by the number 3, add all the digits that make up that number. So 1 plus 0 plus 8, 108, equals 9. 9 can be divided by 3. So we know that 3 would go into 108. And 3 goes into 108 36 times. So let's do this. Let's do 3 because it's a weird number. That drops down and that turns into 36. Oops. And here's another number that can be divided by 3. 3 is a prime number. We're looking for prime numbers that can divide into these larger numbers. So I'm going to use 3 because we both know that both 3 and 6 can be divided by 3. So this is simple, 3. 3 goes into 3 one time, and 3 goes into 6 two times. So you've got 12. And you just keep dropping your little bracket bar things down. And we'll do 2. And 2 goes in there. Goes into 6 three times. And you've now prime factored 108. 108. 99, not an even number, so you're not going to be starting off with the number 2. It is, however, divisible by 3, so I'm going to work through this one fairly quickly. And there's your prime factorization. Now, later in life, depending how far you are in your math studies, you are going to have to write these in a condensed format. There's different names for it. I don't remember off the top of my head the different names, but it is a more concise method of writing your prime factorization. If you were to do this longhand, quote-unquote longhand, for 12, the number 12, you would write out 2 times 2 times 3. That is the prime factorization, the prime factored form of 12. The dots, in case you don't know, are multiplication. Back in grade school, we did multiplication like that. That's fine until you start getting into using variables, which are numbers that represent an amount, you know, x, y, and things like that. It becomes confusing using x and x to represent multiplication. Okay, I digress. Back over here at 12, we've got 2 times 2 times 3 equals 12. Another way that this can be written that is much more concise is 2 to the second power times 3. It's prettier. A lot of math teachers want you to write it in that format. 40 would end up being 5 times 2 to the, since we have 3 number 2's, third. So if you guys have a calculator, you can go ahead and plug in this equation, this problem, and you'll find out that it comes to 40. 55 can only be 5 times 11 because it's pretty much, you know, one step away from being prime. There's no powers because there's only 2 prime factors, and so on and so forth. This one we've got 2 to the second times 3 to the third, and 3 to the second times 11. Now, sometimes people want you to put it in descending order. It doesn't matter. So that's how you prime factor. It's a really great tool. It's slower than being able to do it in your head, but if you're just beginning to work through fractions or basic algebra, you might be overwhelmed, and you might not have all your multiplication tables up to 12 memorized. So in the event that you just have one of those days where your brain won't work, use this. It's great. You get your prime factors and you get your multiples. Let me pick a different color. So everything on the outside of these little brackets, these are your prime factors. And they lead to the creation of these little expressions down here. Bloop, prime factor, prime factor. You get the idea. Everything in the brackets are also factors, but they are not prime. Let me bring up a different color, something fabulous like pink. Everything in these brackets are just plain factors. They count, they are a factor of 55 or 40 or 108, but they're not prime. They can be broken down further. So this is a really neat way to take a number and figure out what it's made of. I hope you enjoyed this. It's my first, and I hope that the audio recorded properly because we've been having issues with this all day. Alright, thank you, and I will be posting more later. If I can figure out how to turn this off. Maybe.